Okay, so hello everyone, welcome to the session. Today, at first I'll go through interpolation, some methods in interpolation. Then I'll discuss about regression, and thereafter I'll discuss about some assignment assignment question, which is assignments which you are given in the previous year. So hopefully, those will help you to solve assignments of this year. So I'll start talking about interpolation. So what exactly is interpolation? Basically, let's say you have some data. Let's say you have some x and you have some y is equal to f of x, and you have some mapping like 0 maps to 2.7, 2 maps to 3.2, 3 maps to 1.6 like that. So question is that suppose there is something that does not have we have the input data only x, but we do not have f of x, some unknown value. So the thing is that can we use all this data to find a good prediction of whatever value this will be? So that is what basically we call as interpolation, because it will be more beneficial if I show you via a diagram. So assume that, sorry, not this one. Assume that I have a graph like this, and there are some points. Let's say let me just draw this only. Uh, like okay, this is in points. It will be difficult to draw. Let me draw it like this. Let's say this is one. This is two. This is three. This is like x-axis, and this is like assume this is like f of x. So assume this is like 10, 20, 30 like this. So assume that there is a point something like this. There is another point somehow like this, another point somehow like this. So these are the points. So the question is that suppose I have a new point like here. Can I determine the y? So this is the question. So intuitively, it will be somewhere along this, right? Similarly, if I say some point here, that will be intuitively somewhere along this. So this is what we call interpolation. But there are one difference. Here you see, like I had 1 to 3, and here when I'm saying find the value for 1.5, that is like within the range of the values of 1 to 3. So that is called interpolation. But if I give a value outside the range, whatever we had already in the data, so like say 1.5, like 4.5 is greater than 3. So this is not within the range. That is what we call as extrapolation. So there are multiple methods to solve that, to find the value of y at a given x given some data. So at first, let me discuss about the interpolation versus extrapolation. So this is basically same only if we are predicting within the given range, then it is interpolation. If it is outside the range, then it is extrapolation. So interpolation is reliable because you see here let's say you assume that there are no here so if I say something like suppose this is a straight line, okay, and if you are predicting some value within that, so there is a very high chance that like you already know this there is a very low chance that something else will happen within this. It is very unlikely that this will be go like this will go like this like that. But let's say you are taking a value here, so it is possible. Suppose you had values are 3 only. Maybe the curve went like this. Maybe it went like this. It is very difficult. It is quite unreliable. You don't know. You know till this point only. You don't know anything after that. So it is kind of uncertain that is it still a straight line after this point or is something else happened. But in this case, yeah, you cannot guarantee that this will be same pattern only, but yeah, there is a very high chance because this is also following a pattern. This is also following a pattern. This is also following a pattern. So within that, there is like you can somewhat be confident that pattern is not changing within this. Like pattern is not like this because this is the straight line. So basically, the point is interpolation is like more reliable, and in interpolation, the curve or line passes through the like near known points, just like this. Like if I have 2 points, I have drawn a line like that. Also, it can be not be a line; it can be a curve as well. Like let's say I have something like this. It can be like this. So it can be something like this. Also, maybe it is also possible that line or curve may not fit a point. Like let's assume that it is like this. So it will be very difficult to come and input this. So that is also possible. So basically, the thing is that in interpolation, we try to draw a line or a curve depending upon the like formulation, and which passes through the known points. Like known points here here in this case means these 3 points. So it may not always intersect with this point, but it will be like quite near of these points as much as possible. But if you say like extrapolation, this is like we have drawn the line this only, but extrapolation will be like outside the range. It is like at this point. So this is outside the line. So this is outside the known range of the data we have. So if you just give an example, like for x equal to 1 to 3, if we try to guess the value between 1 to 3, any value between 1 to 3, that is interpolation. But if it is outside the range, so like 0.5, 0, -1, or 4, 4.5 like this, then it is called extrapolation. Okay, so we will focus mainly on interpolation only, and then there are multiple methods for that. One simple method is like linear interpolation. So basically, what you do here is that assume that you have some kind of a line like this. Assume this is the line, right? And first of all, the idea is that you have to find the slope. Like let's say you want to find the like value between some value here. Okay, you want to find a value of y somewhere around here, but you have two other points. One is let's say one is 3. Okay, and you have to find out 2. So first thing is that this is the x-axis and this is the y-axis. So first thing is that you have to find the slope. Slope is the like ratio between this and this. So how to find that? Why you have to calculate like what is the value of this? No, sorry, value of y, value of f(x) at this point, and value of y at 1. So basically for finding slope, you have to let's assume this is like 3,35. This is just a or 3,40 maybe, and let's say this is like 1,25. So basically, if you want to find this one, at first you have to do is that you have to find the slope. Slope is that y2 minus y1 divided by x2 minus x1. So here like basically y2 is like 40, y1 is 25, x2 is 3, x1 is 1. So basically you are just trying to find out the ratio of the length of hair. So let me take a different color maybe. This one divided by this one. That's it. So this is what we call as slope. It's called m. So after finding the slope, the next step is that you have to uh, calculate. So if we try to find the value, sorry, let's assume I want f of 2. like value of function when x is equal to 2. So what we have to do? We have to apply this formula. We have to apply this formula like y1. So here y1 is what? Y1 is here your this one. So this is like 25 plus this looks like this 25 plus m, value of m here like will be what 40 minus 25 divided by 3 minus 1, right? So it is like 15 divided by 2, which is 7.5. So it will be like 7.5 multiplied by x prime minus xi. So x prime here is like the current value, which is 2, and x1 is 1. So 2 minus 1, which is 1. So the value of y of f of 2 will be 25 plus 7.2, which is like 32.5. So this is what you call linear interpolation basically. So basically you just assume that there are 2 points and you have the values of this point, values of this point. You just have to predict a value of the unknown point, which is here like this. So I hope it is clear. If it is unclear, please like feel free to like ask in the chat or you can unmute. Okay, then if we take a linear interpolation example, like assume that just like I shown in the graph previously, just assume that you have f of 1 is 2.5 and f of 2 is 3.2. So again, for simplicity, let me draw a graph only. So f of 1, let me just also copy this. So here, I assume that we have things like this here. This is 1. This is 2. Here also we have 1, 2, 3, 4. So one thing is that f of 1 is 2.5. So first point is here. And second point is f of 2 is 3.2. 3.2 is somewhere around here. Right? So the question is that I have to find out the value of 1.5. So basically, I just have to draw a straight line compared to 1.5. So how to do that? So basically, what do I have to do? I have to find out y2 minus y1, y2 minus y1 divided by x2 minus. So this is y2 is what? Like f of x is like y, so 3.2 minus 2.5 divided by x2 minus x1. x2 is 2, 2 minus 1 is 1. So it will be like 0.7, right? So what will be the f of 1.5? It will be y1, which is like f of 1, which is 2.5, 2.5 plus this is the slope 0.7 into this is like into we have to give the current value of x, which is 1.5, and the first value of x, which is 1. So it is like 2.5 plus this is like 0.5. 0.5 into 7 is 0.35, 0.35. So final value will be 2.85. Yeah. So this is what we have written here. It is very much more easier to visualize it in through graphs. But here basically I'm just calculating the m, which is y2 minus y1. Y2 is this, y1 is this, divided by x2 minus x1. x2 is this 2, x1 is 1. If you divide that, you got the value of m, which is 0.7, and you just put this into the formula. You have the y1 plus m, which is 0.7, into x prime minus x1. So x prime is the current value of f, which is 1.5, minus x1, which is 0.5, which is 1. So if you subtract that, it is 0.5. So ultimately, after addition, the value is 2.85. So this is obviously very fast because doesn't matter how large your number is, you just have to calculate the m and you just have to calculate the y prime. And you can if the relationship between this function is linear, by linear I mean like if there is a straight line between these two lines, then this is like quite accurate. And but the issue is that assume that you have a point like this, okay, and you are assuming that like their relationship is like a straight line, but it is possible that it is like this. It is like it can be like this, but you are it cannot be like this. Assume that like it is like this, but you are assuming this is a straight line. So what will be your prediction? Your prediction will be this one, but it is possible that your prediction, like actual value, is different. So if it is not linear, then this will not work. This will not give a correct response, very accurate response. And another thing is that this method is used for like 2 points only, but suppose you have 3, 4 points. So this method is not useful in this case. There are some other methods which will come. Okay, so suppose we have more than 2 points. So like this, we have multiple points. Let's say this is point 1, point 2, point 3. Okay, so sometimes it might be possible that you can draw a straight line which intersects all of this line, which is like possible technically. But in many cases, you can see that if you try to draw a straight line between these 3 points, like you can intersect these two, you can intersect these two, but there is no single point which can intersect all three. So what to do? Can you just like intersect these two and can you just intersect these two and like ignore this one, or should you intersect these two and ignore this one? Should you intersect these two? Uh, or like another way is that you can draw in between, like let's say another line maybe here, another line can be like there. Which line you should draw? So the idea is that you should try to draw a line which try to minimize distance between the line and each of the points as much as possible. So here there is something we call as sum of squared errors. So assume that we draw a line randomly. All right. Let's say I have a line like this here. Okay. The question is that how much distance is it from each of the points? This is like, let's say 1 centimeter. This is, let's say 0.5. This is again, let's say 1. This is uh, this is like one line. And maybe I drew another line, let's say like this. This is another line. So if you try to draw the line here, it is like maybe it is 2 centimeter. I'm just giving a rough value. Okay? This is 2 centimeter. This is maybe 1.5 centimeter, and this is like maybe this is, let's say, 0 centimeter. So the question is that if we have multiple lines, there are possibility to draw multiple lines. Which ones will you choose? So uh, the standard is that there is something called sum of let me share this. So what if we want some algorithm which can actually draw it like this, like which covers all the points, not just like in the previous thing. The line may or may not cover all the points, but we want something which covers all the points. So for that, we have something called recurrent interpolation. So basically, it is like this. You have some points, and it will draw a curve which fits to all the points. So it is like something like uh, it will draw like this. So basically, what is the algorithm? We'll come into that. So at first, there are two things. Uh, the notations here. J is the number of the data points you have in your data. Like let's say you have 3 data points, which is present, and you have some an additional data, which is the point you want some value of, and then LJ, which is called basis. So here basically LJ you have to calculate based on this formula. So I will go through one example to make it clear because this can be very confusing based on the equation itself. So uh, before going into example, one thing to note here is that suppose you have a data, you have 3 values, one like value 1, value 2, value 3. So LJ L, it will be like a small l of 0. This small l will be 0 when you are using the you are using any other value. Like let's say if you want, uh, for example, you are giving L0 and you are L0 and you are giving X1. Like let's assume like you have 2 values, uh, 3 values, X0, X1, X2, and you have 3Y, which is Y0, Y1, Y2. So firstly, if you give like if you give anything other than anything other than X0 at L0, then that value will be 0. But if you give like value of X at L0, like value of X0 at L0, then it will be 1. And same for others. So L1, if you get L1 X1 is 1, otherwise it is 0. L2 X2 is 1, otherwise it is 0. Otherwise it is 0. But note that I am talking about X0, X1, X2 only. If there is some any other value, like maybe uh, any value between X0, X1, or any value between X1 or X2, in that case, we have to calculate everything. So let me try to give an example here. Let's assume that we have something like this here. I'm talking about square. Like this is 1, this is 2, this is 3. This is like 1, 2, this is like 4, this is maybe 8. Okay, so if you try to plot here, first point will be one square is 1, right? 2 square is 4, 3 square is 9 here. All right, so you cannot draw a like linear line. Like so to fit this, what do you have to do? In Lagrange solution, at first you have to calculate and the formula is like this. So let's say we have 3 points. You have to calculate y0 l0, y1 l1, y2 l2. So at first y0, y1, y2 are very clear. Y0 is like 1, 4, and 9. Okay. So then next is what is L0. So L0 here is, suppose you want to calculate L0 here. So if you come here, assume that you don't have value verify at X. This is not here. Assume that you just want to use a generic value of this one, generic value of X. So let me just actually copy simplify this for problem. Let me just remove these things. So basically the formula is you already have the y0. So 1 is y0 multiplied by, you have to consider uh, x is something, assume that x is a value which you want to like predict. Okay. So assume that we don't have the value yet. So you can just write uh, from this formula. You also copy this one here. From this formula, what you have to write in the numerator, you have x minus xn. So m means every x value other than itself, like L0. So basically here, forget about this two, y0, L0. So for L0, I have to consider x values of this and this. So it will be like x minus 2 multiplied by x minus 3. All right, and this is done. After doing that, what we have to do in the denominator, we have xj minus xn. So xj is what? Xj is again uh, here. Xj is here like 1. X means this one. So at first, one thing to note here is that x means the unknown variable, unknown value of x which you want to predict, and xj means value of the L0. So here it is like 1. So 1 minus 2 here uh, multiplied by 1 minus 3. So basically what is happening here is that in the numerator, x minus 2 minus x minus 3, in the numerator, 1, which is the current value we are trying to estimate, 1 minus 2 into 1 minus 3. Okay, so this part is done. First part is done. Okay, similarly for next, you have to consider y1. y1 is 4 multiplied by the value here will be x minus 1 into x minus 3. So x minus 1 into x minus 3 divided by 2 minus 1 into 2 minus 3. Finally, for 9 as well, like it will be for 9, you have to consider x minus 1 into x minus 2 divided by 3 minus 1 into 3 minus 2. All right, so this is the equation to find L of x, which is like the value there. So let me try to simplify this. Okay, so first thing is that so what is this x square? Like if you try to multiply it here, what is this? X into x, which is x square. So 1 into within bracket x square minus x square minus 3x, then minus 2x plus 6, right? And at the denominator, you have minus 1 into minus 2. So that is 2. Minus 1 into minus 2, minus will get cancelled. So it is like 2 plus 4 into again here x square plus x square minus 3x minus x plus 3 divided by 2 minus 1 is 1 and 2 minus 3 is minus 1. So it is like 1 into minus 1 is minus 1. So 2 divided by minus 1. Then 9 into here x, it will be like x square minus 2x minus x plus 2 divided by 3 minus 1 is 2 and 3 minus 2 is 1. So 2 into 1 is 2. So when you come to this value after that, if you look at the denominator, here we have divided by 2, here we have divided by minus 1, and here we have divided by 2. Am I correct at this point? Yeah. So then what we have to do, you can take 2 common, right? So it is like you can multiply this with 2 and whole everything will be divided by 2. So you can do it like this. X square, this one, 1 into this one is fine. Then plus 4 into this one into minus 1 also I'm including at the same time only because divided by minus 1 is same as multiplied by minus 1. So this whole thing, you are multiplying by 2 and this thing same only. So basically there was assume that you are taking LCM of 2, 1 and 2. So this is like 2. So you have to multiply this whole thing with 2. So this and everything here it will be divided by 2. This is the LCM. So if you try to simplify that, what will you get? So basically, let me just start multiplying. So it is like x square. This is fine. X square minus 3x minus 3x minus 2x. So it is minus 5x, right? Plus 6. This part is done. Then let me multiply this with this. So here I can just simplify minus 1 I can include within it. So I can do it minus 4, right? So I can take the minus common and I can take it 4. This is also fine. Okay. So this, if you look here, this we can write it as 4x square minus 4 into 3 is 12x minus 4x. So 12x minus 4x is like 16x plus 12. Okay. Plus here like you have 9x square minus 2x minus x is 2x minus x is 3x. 3 into 9 is 27x. 27x plus you have 9 into 12, 2 is 18, and everything divided by 2. Next step, you can just keep the minus inside the bracket. So it will be like x square. Let me just rewrite. It will be like x square only, but here all the signs will change. So it will become this was positive, so it will become negative. This will become positive, and this will become negative. Okay. So right now, see at first let me simplify the x square. So x square here and 4x square here and 9x square here. Sorry, it will be 8x square. So 2 into 4 is 8. So it will be 8x square. 8x square. So here 9x square plus x square, which is 10x square, minus 8x squared. So remaining will be 2x squared. X squared. Then minus 5x, 16x. Just a second. Here also it will be like 24 actually. Here it will be 24. It will be 24. So basically, like minus 3x minus x is 4. 4 into 4 is 16. 16 into 2 is 32. So it will be 32x. 32x, 32x. So basically, plus 32x minus 27, which is 5x minus 5x. So it is like 0. So x value will get cancelled. Then finally, plus here 3 into 4 is 12. 12 into 2 is 24. So it will be 24. Mistake here. I have not multiplied it to 24. So here 6 plus 18 is 24 minus 24 is 0. So ultimately the value is 2x squared divided by 2. So you can, from that equation, you can say that the equation that we are trying to find out is like x squared. So see, even though we didn't know that, like assuming that we don't know that here by like x to y mapping, like it is 2 square is 4, 3 square is 9. We assume that we did not know it earlier, that this is the, like we are just squaring the value. With this equation, I can just like get like recover the like recover the like equation. Now, if the question is that what is the value of f of 1.5, so you can just do like x square 1.5 square. So this is like 2.5. So another thing is that like not necessarily you always have to like do it this kind of like breaking down to get the equation. You can do one thing. You can just take this equation like and you can just place 1.5 in here, 1.5 here, every high 1.5, and you will get the value directly. So this is basically how generally this interpolation works. So there is some assignment question on this. I'll discuss some more detailed example on this as well. So if you have not understood this part, this is also like totally fine for me. Okay, so like this is just something I wrote in a simpler way. So this looks quite complicated here because division is just in the right hand side. But if you look at this, x minus 2 into x minus 3. So this is just the equation what I have written here. So ultimately, like 2 is the denominator in these two, and it is not a denominator here. So you just basically take 2 as common and multiply this part with 2. So 4x square plus 16x minus 12, you just multiply that. So it x square plus 32x minus 24. And then ultimately, nothing will remain for x, nothing will remain for 0, only 2x square will remain, divided by 2, it will be x square. Okay, so another example you can use like it, you can do it in the same way here, like for x cube. I'll like there is some assignment question, I'll come to that. I don't need to discuss this Benjamin. Okay, so code also we can skip on. I'll go to the other algorithms. So then next algorithm is some approximation algorithm. They are called like trapezoidal rule. So basically, I hope you are somewhat aware with integration. So basically, assume that you have a curve here and you have some point from A to B, and you want to kind of estimate what is the like area within this curve. So from A to B, what is the like area? Like area by area, I mean like area, within like below this curve. What is the like surface area? So there are like one way to like one easy way to find this. So assume not really to find it, it is very difficult to find the exact value. Like there is a way to approximate this. So assume it like this. You have a curve like this here, okay, and you draw a trapezium, okay. So trapezium or trapezoid, you draw a trapezoid. So let's say you have the curve like you have like this, and you have the curve like this. You have a curve like this, and you want to find the value like this is like maybe let's say for simplicity it is x0, this is x1. You want to find the shaded area like so this area, all the area like that is present here, you want to find that. So one simple way to do that is that okay, let me draw a different line for simplicity. Let's assume this is the line we are talking about, and this is the x2, and this is the x1. All right. So if you want to like the approximate method is simply you just draw a line from this point to this point. All right. And you calculate this area because you know trapezium or trapezoid area is very easy to calculate. There is a simple formula, and you just ignore this part. This part is ignored. So basically, what happens? Like if you do that, if you just calculate the area of this part and you just ignore this, then the area will not be as accurate because you are seeing that area of this, but actually when you are giving the calculation, you are giving this part only, right? So area is not really, accurate. So then there are some solutions for that as well. But let's start with example with, let's say we have one trapezium or one trapezoid only. Okay. So what is the formula? Here I have to fix something. So here we have integration from like B to A. So means like I want to find the area between this point to this point under this curve. So the formula is this B minus A, which is distance between this and this, multiplied by f of A into f of B. F of A means value of y. F of B means value of like y at point B divided by 2. So basically, this is like assume that like you are just trying to find out the area of a trapezoid, and this is like length, one length, b minus a, and this is like this one is another. Like see, this is the area. Uh, if you look at the point 3, area of trapezium is like half into area of this into half into like area of this into area of this, right? Area of this, let's sorry, area of the big line here and area of the parallel line here. So, sorry, like not this line. Here it is like area of this, sorry, length of this multiplied by length of this plus length of this divided by 2. So this is like, for example, in rectangle, what you do? Like length into breadth, right? But for trapezium, this is the rule, like you have to give this into this plus this divided by 2. So this is like average of these two multiplied by this. So let me try to show this with an example. So for example, we have like assume that you have some rocket and you assume you have a rocket and it is traveling, and you traveling like this, maybe like traveling like this. Like it is accelerating, speed is increasing with time. So assume this is t equal to 8 and this is like t equal to 30. T equal to, okay. So I am they are saying that there is a like formula for calculating the like distance from the ground. So the formula is like this. This is the formula. So the question is that suppose, yeah. So the thing is that at this point, what is A and B? A is this one. A is the starting point in our data. Is the starting. A is the starting point of our data, and B is the ending point of our data, which is 30. So how to like assume that we are calculating this one. So what will be y1 or ya? It will be you just have to in place of t, you can just give the 8. Okay. So if you give if you replace the t with 8 a here, you will get this value 177. Okay. And if you give like 30, the endpoint 961. So basically, I'm saying that here, this is like this value is, let's assume 177, and this value is 901. Obviously, they are not in scale. So the question is that what is the area of this? So area of this is what? At first, you have to calculate this area, this length, which is 22, because 20 like 30 minus 8 is 22, multiplied by 901 plus 177. 901. Is this page descending? 901 plus 177. And we have to take the average. So the area which is under this curve is approximated by this one. So it is basically the x multiplied by y1 plus y2 divided by 2. So like just like square, you have like just like rectangle, you multiply a into b, it is like a, and since there are like b is like two different values, so you just take the average. Okay, so but the issue is that see like here, let me draw a new diagram. Let's say the issue with one trapezium is that, let's say you have a curve like this, okay, but if you draw one trapezium, like let's say from here to here, so what is happening? This area is getting lost, right? So instead of one, what if we do two? If we draw multiple trapeziums, same curve only, right? Let's assume this and maybe this. So instead of one, I am drawing another one here. Okay. And I'm connecting it like this. Connecting it like this. So you see the area here was quite large, the area missing, but here the area here is quite like somewhat similar. So yeah, this is not to the scale, but you get the point. Like the more you draw the trapeziums, the missing space will be lower and lower. So if I show you with a diagram, so if I show you with a diagram, it is like uh, some trapeziums, like if I draw a diagram here, the like if I single trapezium, it will be like this. But if it is like multiple trapeziums, they can have multiple heights, and then it can reduce the free space between which is not calculated, free space between the curve and the trapezoid. So for multiple trapeziums, what do we do? Formula is quite similar to the previous one. So basically, you do so basically you see, let's assume this figure. Okay, assume that there are trapezoids. So we do f of a, which is the starting point, plus f of b, which is the ending point, plus 2 into f of intermediate point. So let's say this is 1 point we are talking. So why 2? Because this is ending of one trapezium as well as beginning of another. So there is 2. Similarly for here, similarly for here. For first and last, there is like only single point, so only single entry. Okay. So you get you are calculate like you have calculated this. So after that, you have to calculate b minus a. B minus a is the length of the x divided by 2n. 2n because how many times you are sampling. So basically, this part b minus a divided by 2, this is common, same as the previous one, right? If you see the formula here, b minus a into fa plus fb divided by 2. So divided by 2 is also common, b minus a is also common. But since you are, instead of calculating once, you are calculating it multiple times. So this value are getting like one value is getting considered multiple times, n times. So you have to balance that, you have to divide it by n. So let me again take an example. Let's say you have n equal to 2. So you are basically, you will be taking two trapeziums, a equal to 8 and b equal to 30. So starting from 8, ending at 30, and you are taking two segments, like two trapeziums. So how to draw two trapeziums? You have to draw everything at equal distance. So basically, let's say this is uh, starting value is 8, ending value is 30. 8 ending value is, let's say, 30. So if I say that I'll draw two trapeziums and there is a curve like this. So if it is one trapezium, it is like this only. If I say two trapezium, it will be like this. Like we have to calculate the midpoint. So what is the midpoint here? 8 plus 30 divided by 2, which is 19. So we have to draw one at 19 here. But assume that you have instead of 2, I am taking 4. So what you have to do, you have to define a step size. Each for it, it is something we call as step size. So this is basically end minus beginning divided by n. So basically, if we take 4 steps, so 30 minus 8 divided by 4. So this is like 22 by 4. 22 divided by 4, which is 5.5. So that means at first point is like 5.5. Then second, it will be like at 8 plus 5.5 is 13.5. Then next trapezium start will be at 19. Next will be 24.5. So at every 5.5 interval, there will be another trapezium like this. So assume that we are drawing two trapezoids. Okay. So we just have to apply this formula. So 30 minus 8 divided by 2 into n. N here is 2 into f of 8, which is the starting point, and f of 30, which is the ending point, plus whatever there is in the middle, and that is multiplied by 2. So f of 19 into 2. Okay. So if you look at the previous example, if you take like if you take f of 19, then if you take f of 19 and calculate with this equation, what is the f of 19, then you will get this value 484.75, and applying this formula, you will get 11,266 meter. Okay, but if you see in the previous, like if you are using only one trapezoid, so it is like 11,868, but here we are saying 11,266. So, but actual value is 11,061. So you see, by using two trapezoids, our value, the prediction value, is actually closer to the actual value. So you see here, like around 800 meter difference was there, but here the difference is around around 200. So this is trapezoid rule. So again, like if you talk about implementation, the formula is like just you have to calculate h, which is b minus a divided by n, and then you have to run a loop. At the outer loop, you are just going through each of the values, and in the inner loop, you are going through each of the points, and then you are sorry, like you have to go through like one loop only. You have to go through each of the points. If it is first point or if it is last point, then it is like multiplied by 1. Otherwise, if it is like interior point, so see here, I equal to 1 to n minus 1, which is like interior points, which will be counted only once. So this, you just like iterate through all of them. You calculate x, which is like a plus I into h. So basically, if you go through the graph, initially it is like 8, then it is like 8 into 1 plus 5.5, 8 into 2 plus 5.5, like that. So you can do that here. Then after getting the interior value, interior sum, you can just use FA FB plus 2 into interior sum divided by multiplied by h by 2. So h by 2 is like basically b minus a divided by n by 2. So this is basically just similar to the single trapezoid, except n is extra here, and for the interior trapeziums, you use 2 into sum. So like for the interior values, you multiply by 2. Okay, so then fine, for interpolation, I have another thing, Runge-Kutta method. So basically, assume that you have to find a value for derivation, and let's say if of x, y is given. Okay, so I'll come to the example in the assignments, but this is the basic formula that you have to, like, let's say you have a value for like y of 1. Now you want to calculate a value of y of 1.1. So first you have to calculate, like first you have the value of y of 1. You have to use that plus 1 by 6 into h. H is the step size. So step size here is that it will be like there will be like 4 steps. So actually I'll come to here. Okay. So assume that you are starting with 1 and you need a value of 1.1. Okay. So there are 4 steps. At first you have to find k1, which is f of x0 and y0. So f0, x0, y0 is whatever value you had earlier. So f of 1 is let's say 5. Okay. So here, if here is it, you should give 1, you should give 5, you should calculate the value of the function, and that value is k1. Then in the second step, you should use 1 plus h is the step size divided by 2. Okay, so this is like, let's say you want to find 1. So here you should find 1.05. Sorry, like suppose you have 1 and you want to find 1.1. So here you have to find 1.05. Okay. And here also, like it will be like y0 plus k1, which is whatever you have obtained here, multiplied by h by 2, which is like the step size here is like step size there is 0.1 divided by 2, which is 0.05. Similarly, for K3, you have to use the x0, which is here 1, plus h divided by 2, which is 0.05. So here f of 0, like 1.05, comma, y0, which you had earlier, let's say 5, plus K2, which whatever you have obtained here, multiplied by h divided by 2. H is here, let's say 0.1, divided by 2 is 0.05. Like this. Similarly, for K4, you have to apply f of x0 plus h. So here, see, here it is like 1, 1.05, 1.05, but here it is 1.1. Okay. And then from y0, you just have to use the K3 value multiplied by h. So it is like 0.1. So I will show an example in the assignment. It will be more clear from there. But these are the like basic formula that you need to like consider. And after you got all the values K1, K2, K3, K4, you have to calculate with this formula y0 plus h divided by 6 multiplied by this K1 plus K4 plus 2 into K2 plus 2 into K3. Okay, so I'll come to the before that, I'll quickly discuss about recursion. I hope almost all of you know this, what recursion is. But it is basically like if I call a function by itself, directly or indirectly, then it is called recursion. So here, let's say iteration. The first is that what's the difference between iteration and interaction? Iteration and recursion. So iteration is basically if you run a for loop or if you run a while loop, then it is like called iterating the values. So for example, for adding the number, you just run a for loop, or for like adding the number, you can also run a while loop, giving a condition. Okay. But this can also be done by calling a function again and again. So this is what we call recursion basically. I'll come to that. So there are two kinds of recursion. So one is deduct recursion. So suppose we have a variable called factorial, and within the factorial, we are calling factorial again. So this is called deduct. Okay. Another one is that let's say we have a function called isEven. Within isEven, I am calling isodd. Within isodd, I am calling isEven, like that. So like one is calling another is calling the other one. So this kind of indirect, like if there is some indirect connection, they are calling each other, then it is called like indirect recursion. Okay. And in recursion, there must be two things. One is the recursion form. Like let's say I am trying to find factorial of n. So factorial of n is what? Like let's say factorial of 5 is what? 5 into 4 into 3 into 2 into 1. So what I can do is that I can write 5 multiplied by whatever factorial of 4 is. Right? So this is a recursive form, but it should not happen that it will go like 5 into 4 into 3 into 2 into 1 into 0 into -1 into -2. So it should not go indefinitely. There should be a condition that if this condition is satisfied, do not do further recursion. So taking the simple example for like factor is like if I take 5 into n is equal to 0. So that means I'm saying that like initially I'm starting at 5. I'm saying 5 into factorial of 4. Then I'm saying 5 into like instead of factorial 4, I'm saying 4 into factorial of 3. Instead of factorial 3, I'm saying 3 into factorial of 2, like that. But when I'm going to n equal to 0, I'm saying no more factorial. We will not go to negative value. We'll return that 1. So here, this is the chain. Factorial 4 will consider 4 into factorial of 3. This will call factorial of 2. This will call factorial of 1. This will call factorial of 0. But then this is the final value. There is nothing here. So it will start adding, multiplying here basically. 1 into 1 is 1, into 2 is 2, into 3 is 6, into 4 is 24. Okay, so factorial 4 will come as 24. Similarly, you can do some other things like greatest common divisor. So basically, suppose you have written an algorithm that if m equal to n, so if both of them are equal, then return m. Otherwise, if the first one is greater than the last one, then like subtract first one from the last one, and otherwise subtract the second one from the first one. First one from the second one. So basically, let's assume that we have 70, 15. Okay. So this value is getting satisfied, n is greater than n. So then again, it is calling 60, 45. Again, this value is getting satisfied. So 40, 45, 15, 30, 15, 15, 15. So when m is equal to n, so both of the values are equal, then we can say that they are same. So they like the GCD of this like 70 and 15 is 15. So these are the some recursive ways. Similarly, you can use Fibonacci series, like let's say uh, Fibonacci is like it is like 0, 1, then you have to add 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, like that. So let's say I have I want to calculate Fibonacci value of 9. So I have to take f of 7 and f of 8. So we can just do it with recursion. Like f of 7, then when it goes to f of 7, it will calculate f of 7 and f of 5, f of 6 and f of 5. Similarly, when it goes to f of 8, it will calculate f of 7 and f of 6. But ultimately, we should have a base condition that f of 1 is 1 and f of 0 is 0. So if any such cases are there, then we should return that. So basically, it will form a tree. So Fibonacci of 4 means we have to add Fibonacci of 3 plus Fibonacci of 2. Then again, if Fibonacci 3 of 3 means we have to calculate Fibonacci of 2 and Fibonacci 1, like this. So this kind of tree structure will come in recursion. Okay, and how a recursion is implemented? Recursion is implemented through stack. So suppose you are calling a function. So whatever value we have there in the current function, they are pushed into a stack, and the control is transferred to the calling function. And in that function, like when all the calculation takes place, then when it returns the value, then again those things are popped back from the stack, and then they are used again. So what is the difference between iteration and recursion? Recursion, for iteration is like it is like you are running by a loop, but in recursion you have to make a function like multiple function calls. Okay, and in both the cases you have to keep in mind that they can go to infinite loop if you don't handle the best conditions. In iteration, you don't really need extra memory except for int I equal to 0, I less than n, I plus plus. So in this case, only you need just the I. But in case of recursion, you need the memory because everything is getting stored in the memory stack. So there is memory overhead. But what is the advantage of recursion? It is it is very most of the time it is very code is much shorter and it is very difficult. It is very easier to understand compared to the loops if you understand the concept of recursion properly. And another thing is that let's say it can be also very useful to divide a problem into multiple parts. So let's say in case of binary search uh, or merge sort, what we do is that we divide a array into multiple parts. So what we can do is that we can decide that this is the midpoint, and we can decide the solution is in the right side, and then we can use the recursion to call to search within the right side only, like that. So this is the difference in the code. I'll then this is, I think you are already aware of these things. So I'll come to the question now for assignments, previous year assignments. At first, we'll start with MCQ, and then there are some other problems as well. I'll come to that. So this is the first problem. Please write your answer. Shanvita, you can unmute yourself. You can ask the question. Microphone is allowed.
Thank you, sir. I have a doubt. It is not related to the syllabus.
Mhm.
The thing is, I recently joined the course and the programming assignments, those I have not submitted. So I've done the quizzes and everything. So I was wondering if the programming assignments are counted for the 25 marks or no.
Actually, I am not sure about that. I am actually the course instructor, but I think it is counted. I think. Like, is anything mentioned in the course?
No, sir, it was not mentioned. It
Let
was
me go
just
to
said that there will be a 10-mark assignment and it will be scaled down to something and added up to your 25 marks. So I don't know.
okay. So actually, I'm not sure, but actually, in the assignment page, it is written that it is credit assignment. So I think it will be credit.
Um, okay, so I have not submitted those.
Like it will be somehow considered.
Sorry, sir.
Okay, so can you post
What should I do, sir, if they are actually counted and I don't get marks above 10?
hello, am I audible? So basically, there is a column here, Q&A. So there you have the like course TA, teaching assistant. So if you write it here, new conversation, you just write it here, and all the official persons will reply. Official in charge will reply. So you can ask like,
Where should I ask this, sir? I'm sorry, in the
okay, so
Google form that's updated.
yeah, so here like this is the course page, right? So here you go to the Q&A, continue,
Oh,
and
okay, sir. Yeah.
new conversation.
Okay, sir. Yeah. Thank you.
So let me go back to the assignment.
Sir,
Yeah,
sir, please could you show the Newton Raphson code?
Newton Raphson code. I don't think I have prepared in this week's slide. Um, Maybe I can show you in the next week. I have not
Okay, sir.
considered that. I'm writing this. I'll remember. Okay. Any solution for this? So actually, both of the statements are true about interpolation. So it is for finding a value between 2 points or on a line or curve, and it is like if it is like you're estimating some value given the some like given some points you are estimating some value at the some of the intermediate point. So they basically mean the same. So okay, this is a little bit lengthy, so I will solve the question obviously. Uh, but can anyone try to solve maybe L0 of x? This what only. I'll give you some time. 2 3 minutes I'll give. If let me also copy the equation. Complexity. So equation, if you remember, it is from earlier. This is the equation, right? So these two are the equations. So here we are saying that I have I'm asking you to calculate this one for L0 of 12. So if you remember, like it is the formula was that L0x into y0 plus L1x into y1 and L2x into y2. So see 19.45 y1 y0 y1 y2 we have already written. Now we have to find out this one only, and we have to put the value here, and we can just get the result. So if you consider L0, okay, so for L0, what is the thing? It is like x minus xn. So it will be repeated for every values here. So except for j, j is 0. Okay, j is 0. At first j is 0, then we have to consider everything. J is 0, j is 1, j is 2. For j is equal to 0, we have to calculate L0, which is we have to here we have to calculate m where it is not equal to j. So here we have to consider the values of 1 and 2. So here what is this? X is equal to x is at 12. 12 minus here 15 multiplied by 12 minus 20, right? Divided by anybody was it out?
No, sir, I've written the answer.
Okay, so is this a full answer or you are saying the value of LJ?
The value
is-
of fx at x equals to 12.
Okay, right. Oh, I think you are correct. I'll come to the solution. I think you are correct as far as I remember. So this is like 12 minus 15 into 12 minus 20 because 12 is the value we are trying to predict and 15 and 20 is the value that is not that is not x0. Divided by, I have to construct 12 minus 10, sorry, 10 minus 15 into 10 minus 20. So basically 12 minus 15 into 12 minus 20 and divided by 10, which is this value 10 minus 15 into 10 minus 20. That's it. So this is basically 12 minus 15 is minus 3 into minus 8 divided by minus 5 into minus 10. So this is what? 24 divided by 15. So this is like 0.48. So this is like L0. So I have calculated properly here. Similarly, this is L1. You just have to consider 12 minus 10, 12 minus 20, not 15 because 15 is like 1 here, divided by 15 minus 10 into 15 minus 20. So it will be like minus 16 divided by minus 20, minus 25. So it will come out to be 0.64. And then L2 you have to consider 12 minus 10, 12 minus 15 divided by 20 minus 10 into 20 minus 15. So it is coming out to be minus 0.12. So if you put this value into the equations, this is 0.48 into 19.45 plus 0.64, which is the value we got here, into 10.63, which is here, plus minus 0.12, which is like L2 multiplied by 7.82. So if you add this, you will get the final value, which is 15.2008. So your value is little bit different from whatever is here. Please check. I think you got 14 point something. Okay, so let me go to the next question. So you have a integration and starting from 0 to 3, and you have this equation. So what is the area using like only one segment? So what is B minus A here? Okay, can anyone answer what is the like B minus A and also what is F of A here? These two. B minus A is 3, right? So B is 3, A is 0. So this is 3. Yes. Okay, so let me just write it here only. So I just have to apply this formula, right? This formula. So this is like B minus A is 3 multiplied by F of A. What is this? What is the value of F of A? So what is that? F is basically this one. F of X is equal to basically X square in the power 2X. So if you just use 0 instead of X, what will be the value? So I need to calculate F of A and F of B. So what is the value of F of A? So basically, if you just put 0 here, X square is like 0 into 0 is 0. So any value comes here, it will be like 0, 1. So this is 0, this part is 0. Okay. The next part, X square. So this is like 3 square. Okay. 3 square is 9. 9 into e to the power 2x. So 9 into 9 into e to the power 2x. X is what? 3. So e to the power 6. So this is this value. 3680. This one. So 0 plus this one. Okay. So if you calculate this, what will be the output? So you just divide this by 2, multiply this by 3. So the value is 5.46. This one. So I just here I have shown this with step. So f of 0 is 0, f of 3 is 3, 3 minus 0 into f of 0 plus f of 3 divided by 2. It is this one. Okay, so here we don't really want you to like calculate the value. We just want that suppose in RK, Runge Kutamitar, like what will be the value? Like how should we rewrite it? So here basically what we have to do is that like we have to take everything other than dy dx to the right hand side. So if we take everything to the right hand side, what will be the answer? Okay, so in the last question, generally they accept some range, okay, but that range will be mentioned in the question. Like if it is in exam or assignment, like they will mention that right up to this many decimal points, and you round up to that. So any answer for this question? Answer is the okay. Yeah, so C is correct option. So basically, just for a moment, ignore this part. Why is of 0 is equal to 5? So at first thing is that you have to move this part x square ex to this here on the right hand side. So plus here will become minus. So this one and 10 is multiplied with dy dx. So if it is in the right hand side, it will get divided. So like it will be like 1 by 10 into this one minus this one. So C is the correct option. Then question 5. This is quite a lengthy question. I will give you a formula, and can anyone answer what is the like? This is the formula. So can anyone answer what is the like K0? Or sorry, it is K1. So let me give the formula. It's simple here. Let me just copy the whole slide. Okay, so I want to calculate. So this is f x of y, x and y. So I want the value of k1. So let's set this. Okay, so uh, k1 and x0 is what here? X0 is x0 is 0.5, right? So this is the value x0 and y0 is 2. Okay, so can you find out the k1 here? This is the f. So basically here you are given this equation, but see in RK4 method, you have to consider in the left hand side, you have dy dx only. Everything is else in the right hand side. So y cube minus x square, it will become, and then 4, it will be like 1 by 4. So f of xy is 1 by 4 into y cube minus x square. Okay, this is the formula. Now, k1 is f of x and y, and x value I am saying that it is 0.5, y values I am saying it is 2. So what will be k1? Just put the value, like here you just put 2, here you just put 1. That's it. So k1 will be 1 by 4, 1 by 4 into 2 cube, which is 8, minus 0.5 square, which is 0.25. Right? So 1 by 4 into 7%. So this we got the value of k1 here. Okay. Now k2. K2. So using this formula only, find out the value. So h1 here is that, see h mentioned here, h is 0.2. So what will be h by 2? It is like 0.1. So k2 is equal to f of 0.6 and y0 is 2 plus k1 is 7.75 divided by 4. Two plus this multiplied by h is 0.2 divided by 2. So h is 0.2 divided by 2 is just 0.1. Okay. So it is equal to again is equal to f of 0.6 and this adding 2.19375. So these are the values of x and y. Okay. So if you apply this function again, y cube minus x square, what will be the value? This to the power 3 and this to the power cube. Sorry, this cube minus this square divided by 1 by 4. So I'll not go through all the steps calculation because calculation is complicated. So I'll just show the steps here. So see, just like that, I like achieved 1.9375 on k1. Then using value of k1, I am calculating the value of k2. So k2 is this equation, k2 k like for the next x the value is 0.6 and for the next y the value is 2.1975. So if you put this formula 1 divided by 4 multiplied by y cube minus x square, the value is 2.54937. So at this point we got k1 and k2. Then what is the formula of k3? K3 formula is that x0 plus h divided by 2, so which will again become 0.6. And this one is y0 plus k2 into h divided by 2. So earlier it was k1 into h divided by 2. Here it is like k2 into h divided by 2. So here this is again 0.6 and this is 2 plus here it was 2.5497 2.54937 multiplied by 0.2 into divided by 2. So it's like multiplied by 0.1. And if you add that, it will become 2.2549. Okay. So you got the value of like you got the like y here, you got the x here, and if you put it into the equation, y cube minus x square divided by 4, you will get this value. So K3 is also done. Next part, you have K1, K2, K3, you have. Finally, here, note that there is no h divided by 2. So in the first step, there is no h. In the second step, there is h divided by 2. In third step, there is h divided by 2. And in the fourth step, there is like h. And another thing is that here, every step is using the k value of the previous. So K1 is using nothing. K2 is using k value of K1, K3 is using value of K2, and K4 is using value of K3. So by that you can remember. So K4 formula is this. K4 formula is like x0 plus h and y3 into K3, y0 plus K3 into h. So here, since you have h, you will get 0.7, 0.5 plus 0.2. And here you have 2, which is the y0, which is 2 here, plus the K3, which is 2.77645 into 0.2, which is the step. So final value is 2.555. And again, you will use the y cube minus x square, and you will get 4.0486. So these four are the values, K1, K2, K3, K4. Then how to aggregate all of them? You have to use this one, like 2, which is the y0, first value y0, plus 0.2 is the step size, okay, divided by 6, which is like constant, then K1, K4, and 2K2, 2K3. So if you add all of this, the value is like 2.55459, so it is like 2.5546. So yeah, this is quite complicated, but if you remember the steps, and the steps are basically for K1, there is no h. For K4, there is h, and for K1, K2, and K3, there is like h divided by 2. And every step is using the k from the previous step, except for K1, which is like not using k at all. So you should practice this kind of questions. Okay, then let me go to the next question. What will be the area under trapezoidal rule? So you have a trapezium, and there are multiple points. And in this case, the first is counted once, last is counted once, and everything in middle is counted twice. So what will be the area? I will continue with solution. Time is limited time. Okay, so basically what we have to do is that this is the formula h divided by 2, and y0, and y0 is first point, y4 is last point, and we have multiple points in between. Okay. So each here is basically the step size. So also, like, you can, instead of each, you can also write b minus a divided by n. So these are equivalent actually. Let me just write here. Like, instead of h, you can also write 2.2 minus 1.4. So this is what 0.8, and there are like four intermediate points. So it is like 0.2. So like h is equal to b minus a divided by n. So like here, let me continue. So basically here, this is equal to 2.2, let's say increment size. Here 1.4 to 1.6, so it is like 0.2, 1.6 to 1.8 is like also 0.2, and divided by 2 at the end, like everything. 4 point, this one is first, this one is last, and everything is multiplied by 2 and added. So if you calculate these numbers, it will come out to be 4.32. Yes. Okay, next question. Root of the equation. So again, I'll like suppose this is an equation. The question is that at which value of x you will have actually 0, like in the equation is 0 at like which value of so basically let's assume let's be like there can be two methods to solve this. One is bisection. So let's assume that I took two numbers, 1 and 0 to start with. Then I'll calculate the midpoint, which is 0.5. Then I'll calculate f of xm. So xm is basically this midpoint. So I'm basically saying that instead of x, I'll write 0.5. Then I'll calculate the value. I calculate the value and the answer is minus 0.2552. So if the value is minus, then midpoint will become the lowest point in the next step and up point will remain the same. Okay. So again, I calculate the midpoint, calculate this one. So now the value is 1.28. So 1.2 is more than 0. So in this case, 7.75 will go to the here upper position and lower position will remain the same. So this is the if it is greater than 0, then like midpoint will go to the upper, and if it is lesser than 0, then low point like midpoint will go to the lower. Okay. So if you continue this for multiple steps, you at some point you will come at a value. So see the middle is changing. So at this point it is like 0.5469, 5391. So you already got a range that it will be within this range only. So this is one method with bisection. Another you can use neutron raption. So in this case, you have to, this is the function and this is the derivative of the function, because if you just take ddx of this equation, this is 5 and cos 2 is coming outside. If you take derivation with respect to cos x, it is like minus sin x. So minus it will become plus 5 plus 2 sin x. This will get cancelled. So Newton Raphson method, the formula is that x of n plus 1 is equal to xn minus f divided by f prime, like derivation. So basically, let's assume we are starting with 1. So if you put 1 to this function, the value is 2.91. If you put 1 to this function, the value is this one. So if you apply this function here, like 1 minus this by this, then the value is this one. Then next step, start with this one. Again, put the value of x here, and you will get these two values. And then if you apply this and this here, and xn is here, we'll get this value. So like this will continue. And after some point, you can see that there is no further improvement here. So this is the final value, 0.542563. So you can say that this is within this range. Okay, so there is another MCQ. Bisection method is guaranteed to work for finding all roots for all continuous functions, assuming that there exists a root. Okay, so is this true or false? Then trapezoidal rule is a technique for approximating indefinite integral. So is it true or false? And Lagrange polynomial is for polynomial interpolation. Is it true or false? So the question is like, it is what, which is false, not which of them are true. So in first question, also assume that you have like f of a and f of b multiplied is less than zero. Okay, so like you found the ideal position, and can you guarantee that it will find that? Like you know that the root exists between these 2 points. Is it guaranteed that you'll find that? No, so only a one. So this is not really correct. So basically, if you go to diagram here, I am saying that let's say you have a SIM card here like this. I'm saying that I have already found a point one and point B, and here they are like f of a and f of b is f of b and f of a is less than zero. So that we already found. So in that case, we can actually guarantee that like we'll find it here, then here, then here. Like ultimately we'll find the midpoint, like the root. So this first statement is actually true, given this equation. But the second question, second point is not true. Here you can see in case of trapezium, uh, yeah. So you see, it is not really indefinite. Indefinite means like integration like this. Integration effects. There is no value here. There is no value here. But in case of definite, it is like A to B. So from A to B, what is the area? So if you're trying to like calculate area within indefinite range, there is no bound. It is not possible with trapezium. So like because trapezium length, it has to be bounded, right? Between some range. So this is not correct. So only two is wrong. Lagrange polynomial is used for polynomial interpolation. This is also correct. So third is also correct. One is also correct. Two is wrong. So correct option is answer B. Okay. So again, this is about bisection method. So I'll go to the solution only. So here, in the question, they are saying that start with 1.5 and 2. So I'm starting with 1.5 and 2. Midpoint is 1.75. I am putting 1.75 into this equation. So this is minus. Minus means this will go to the lower A. Minus means it will go to the A. Again, I'll calculate this is plus. So this will go to the B. Minus, so this will go to the A. Again, minus, this will go to the A. And this is like they told 5 steps only. So after the 5 steps, we have like f of m equal to this one and m equal to this one. So this is the root after 5 steps. Then final question, match the following. So which of the method is used to do what? Yeah, like assuming that I told like assuming that root exists between these 2 points. So yeah, if it is complex, you cannot find. But in the question, I told you to assume that it does exist. It is linear. Okay, everyone is answering A here. And yes, A is the correct option. So basically, Newton method is used to find like root, just like I showed in the few earlier slides. Then trapezoidal is obviously used for integration to find some area between 2 points. Lagrange is used for like Lagrange is used for like interpolation, like to fit a polynomial. Uh, then Runge-Kutta method is used for like a differential equation. You have like f of 5, what will be like f of 6, like f of 5.1. So, okay, so this is the end of the session. I will end the session, and yeah, next week I will discuss about the Newton induction coding, and also cover structure in the next week. Okay, so any other questions? Okay, so I will end the session then. Thank you very much for joining.